So my name is Dan Pechi. I'm a senior GenAI product specialist here at Databricks. I work with a lot of our startups and digital native businesses, but in my role, I kind of work between research, product, and actually talking with customers, hearing what actually matters and what is impactful for you all. One big thing that I think is a big takeaway in startups and digital natives, in addition to enterprise customers, is we see people thinking about GenAI as being this big, scary thing that requires all of this re-enablement and relearning. And hopefully by the end of today's talk, you'll see that, hey, GenAI is maybe not all that scary, and it's actually more familiar than we might think. Analyze this through the lenses of RecSys, topic modeling, and everyone's favorite subject, because it couldn't be 2025 and talking about AI without agents. So high-level overview. I mean, does the clicker click? It doesn't. OK, that's fine. So yeah, we'll kind of talk about what it means to reinvent the wheel and cover these three areas, and then we'll have a very beautiful demo. But before we begin, this is an agent architecture. Does anyone want to guess and tell me what year this is from? Any numbers? Like, please shout them out. When was this agent architecture designed? OK, I mean, people said like 50s and stuff. No, it's from 1993, but the more broadly illustrative point here is that agents and a lot of these other GenAI paradigms, or at least the problems that they solve, are not uncommon and have been around for a while, right? Let's talk about it from our perspectives, though, right? What does it mean to reinvent the wheel with all this? We've probably seen all sorts of crazy GenAI for things that you probably don't need GenAI for. But before GenAI, we had this familiar paradigm of what we consider preferred qualifications for someone looking to do AI and ML, right? I'm not going to go through all of these, but these are some of the things that we would consider when it comes to evaluation, when it comes to the broader life cycle of building AI and ML models as part of broader products, right? And there's also a post-GenAI world in which some of this is the same, right? But there are some things that are going to be different. I highlight the orange ones as being pretty similar, and we'll highlight this as part of this talk as well. But some fun ones I'll call out are just these libraries, right? Cool, sklearn and PyTorch, but have you actually built something with LangChain? Have you built something with MCP, DSPy, so on and so forth? These paradigms didn't exist 2 years ago, right? So there is some relearning to do. There is some upgrading of the wheel, right? But what's nice is we can still see there are parallels in some cases, and then in some cases there aren't, right? Oh, pre-training and fine-tuning? Well, how about parameter-efficient fine-tuning, or any of these other concepts that prior to, I'll say, like 2022, 2023, did not exist at all, right? These are things that when you're looking for someone who does these things, ideally they can explain to you what prompt caching might mean, for instance. So as it turns out, there are some ways in which we're not just maybe reinventing the wheel here, but there are fundamentally new things with GenAI that are challenging. And we hear this even more so for ROI and delivering ROI, right? All of these things existed before GenAI, especially the claim that, oh, there's no ROI here, right? With GenAI, we see that especially to be the case, right? And a lot of this is just inertia and industry adoption, right? We are all working to enable ourselves, myself included, on this new paradigm, and it means that we kind of need to be up to date with things. But we also see all sorts of other fun ways in which people look at GenAI differently from there being ROI. McKinsey put out a report in the early days saying, we're going to get crazy employee productivity gains. How are you supposed to measure that, right? How are you supposed to build KPIs around that? You don't have like an A/B test of employee A used GenAI and then employee B didn't, and we see some fundamental difference there, right? There's other things around costs, and we might also need subject matter expert feedback. That doesn't exist for a logistic regression model necessarily, right? There's statistical tests, there's key metrics where if you don't do well on that metric, it's bad, as opposed to, hey, I'm working with my payroll team, and the payroll team said that the agent hallucinated. Great. Like, what do you make of that? How do you track that, right? It's challenging. There's other things here, but big picture here, think about use cases, right? When we think about traditional ML, right, we'll say, oh, this is a forecasting problem. Let's solve it that way, right? GenAI people kind of just said, oh, ChatGPT. Oh, nice. Like, let's build ChatGPT, and maybe there will be profits. No, same thing, right? We need to think about use cases first and where certain models fit the bill for being necessary there or not. So the more things change, the more they stay the same. This is to say we have a lot of different problems that existed before and after again, thinking about this from a use case level, that had traditional solutions, and then there's LLM-based solutions. Some of these models might not even involve actual machine learning in some cases. We'll highlight some of these, but this is all to say that there's a new way of doing these things, and part of this talk is to differentiate when that might actually be helpful or not, right? I was talking with someone today about time series forecasting. They have an ARIMA model. Do you really need to use a large language model that's perhaps like millions of times the size of it and probably costs more to like host and all of that? There's some cases where it's even more obvious, right? Someone has a paper on doing linear regression with language models. If you are doing that in industry, your boss is probably not going to be very happy. So, just to kind of summarize this, Andre Karpathy has a nice tweet here. We kind of have this thought that we can throw an LLM at it being any of these problems that we might have had before. Whether it's actually the right solution, right, is an entirely different question. But people kind of are using, and in some cases abusing LLMs to solve problems that, again, may or may not actually require us to reinvent this wheel, right? So again, we're solving the same problems, but there might be alternative GenAI solutions. How do we start to think about whether one might be better than the other? The point of this talk is not to give you a prescriptive best practice, like, oh, if your data looks like this, go use the GenAI version of the solution. If it looks like that, go use the traditional one. What we'll show is the Databricks platform lets you kind of experiment and evaluate with all of these things side by side, because we've been doing traditional ML for a very long time, and GenAI fits in neatly with this broader way in which we think about models and models combining with data to provide data intelligence. So let's talk about topic modeling. This is the easiest kind of way in which we can illustrate this out. You might have heard of latent Dirichlet allocation. We'll walk through this in a demo as well, but I'm not going to get into the specifics there. LDA has been around for a while. TF-IDF is another one. It is kind of an out-of-the-box solution, right? Look at this nice little code snippet. That's effectively all you need, thanks to PySpark. But there's all sorts of issues with this. I'll show this in code actually in a bit. I want to highlight this other paper that kind of bridges the gap between these two things using a BERT-based model. It works a lot better than LDA, which is meant to be out of the box. One big thing with LDA is it's kind of a clustering algorithm rather than a topic modeling algorithm. But there's still cases where this is not going to be quite as robust as we might expect, and that's where LLM-based approaches make a little bit more sense. Ultimately, you get greater flexibility and can iterate a lot faster as well, right? If you see that there's something wrong with your topic modeling approach, well, hey, why not add in some component to that prompt and specifically address that and get better performance and be able to hill climb over time. So let's talk about the GenAI approach to topic modeling. You can imagine we have a bunch of unstructured text data. I see people working with like client meeting notes, right? And they want to get the topics from those client meeting notes, but they want it to be pretty consistent, right? Maybe it's about future business relations. Maybe it's about a current contract, et cetera, right? We can have these different pieces of text. Imagine it's variable length, which means we need something that also works at scale. What we can do is, using Databricks, we can generate topics at a per text grain, right? So we might have this be independently generated for each meeting note summary. And then this is helpful, but what we really want is to narrow the scope. Each of these are generated independently of one another, which means they might be something totally irrelevant, and there's not clear clusters, right? So the next step is to do that clustering. This is super cool because we can actually combine traditional ML approaches for doing clustering, because fundamentally, these texts are things that we can pass to an embedding model and then start to see in space where they all sit amongst each other. Alternatively, you just pass it to an LLM, right? This is kind of the LLM versus traditional ML step here, right? Instead, you can just pass it all to one LLM and say, hey, summarize this into a couple of topics, right? With those new couple of topics, right, we can then reclassify what we originally had from these initial topics to more consistent topics and ultimately get something that's going to be more reasonable. This is all helpful, but there's also just a paper that did this as well. As it turns out, you can just do prompt engineering and get papers published in major computational linguistics conferences. Not knocking them by any means. This is really great and helpful research, but the barrier to entry is super low. And there's a lot of positive impact here because we effectively redid the algorithm that had been kind of a standard for something like 20, 15 years. So LLMs can really change these things, and generally speaking, this is one of these cases, and I'll demonstrate this later in the demo, where the GenAI solution can be a lot more powerful and more robust than anything you might get otherwise. Let's talk about recommender systems. Recommender systems have also been around for a very long time. Databricks partially founded as a result of Netflix's challenge for RecSys. So RecSys is an approach that has traditionally been done with collaborative filtering. I don't want to talk too much about it, but feel free to just look at that nice little diagram on the right for a long while. In short, it is vector-based similarity, right? For anyone that is just getting into RAG, you'll be like, oh, that sounds familiar, right? Guess what? That's also vector-based similarity. As it turns out, there's more in common with the traditional ML paradigms with the current modern GenAI approach than we might think. In this case, you kind of identify users or products, and if you're recommending a product to someone, we might say, oh, this product has a similar representation of users that like it to some other product you might have bought. And then we will say, hey, these two vectors have high cosine similarity or other distance-based metric, thus let's recommend it. That's the short of it. Again, we're not going to get too into it. Also amazing, PySpark, providing a really easy way for us to just get this out of the box. There's all sorts of fun hyperparameters here. It also is pretty compute intensive, just calling that out. But in short, this has been done for ages, right? Collaborative filtering as an algorithm, that's a almost 25-year-old algorithm. You can see what this looks like as part of a broader architecture. Again, like Databricks is great for this stuff because it works nicely at scale. But we also have this flavor of collaborative filtering where we start to talk about integration with vector stores and feature stores. We can also talk about LLM integration here as well. Vector stores, seem to have only come into existence in the last couple of years, but guess what? People have been doing this cosine similarity problem at scale for a very long time. They probably built something that looks a lot like your modern day vector store. And now, like traditional search players, right? Like I think OpenSearch is a good example. They now have a vector search because guess what? This is the same exact problem as before, just being solved or thought of in a new way with GenAI. Here we call it feature stores, but there's an even more kind of LLM-oriented way to do this because arguably this doesn't involve any GenAI. Maybe your vector embeddings are actually like text embeddings from like BGE models or something like that. But to combine this with LLM inference is pretty straightforward, right? In the stupidest way possible, right? This prompt kind of spells it out. A user bought these things. What are they going to buy next, right? That is a prompt-based solution. This is, again, dumbing down the problem significantly. But fundamentally, this is kind of how we see customers thinking about RecSys in this more GenAI-based context. Maybe, in terms of these items, we're also looping in some of the recommendations from that traditional RecSys model and saying, a user bought the following items, and we think these 3 items are going to be popular with them. Which one of the 3 should we recommend, right? And we might have natural language descriptions of those products. This is, again, like oversimplification here. But again, hopefully you're seeing, hey, this is the same problem, and we can maybe get, I don't know, like a 5% performance boost just by leveraging some GenAI paradigms with it. You can see there's some nice papers here too. Shashank, the second author of that paper, actually works at Databricks now. But yeah, as you can see here, it's kind of getting back to that prompt-based approach. We can see, okay, which tokens are we going to predict to have the highest likelihood, right? This is how we can start to think about recommender systems as being something that is just based in large language models. As Andre Karpathy says, it's kind of this autoregressive classification system. That's really the power of LLMs, is we can transform it to fit any number of these different tasks. Let's talk about the last one. Like I said, can't talk about GenAI without talking about agents. But to my point, I call it deep RL here as being 2014, but RL and the concept of agents have been around much, much longer. So again, like this is from 1993. People were thinking about agents then. They were thinking about how to make these systems that can act semi-autonomously to solve specific problems in a more dynamic way. But I had some fun like jumping down this rabbit hole. Not the first mention of agents. You have to go back to 1973 for this planner actor agent, which plays a role on queue according to a script I don't know, that kind of sounds like saying, hey, I have a prompt and I'm feeding it to this quote unquote agent that is making decisions. I don't know what this actually looked like. It maybe didn't even involve like actual code, TBD. But let's talk about traditional RL for those that might be unfamiliar. We're actually going to go back to this diagram a little bit later. In traditional RL, right, your agent is just as important as your environment, and your agent takes actions in that environment. We'll walk through a example of this. That is going to do two things. One, it is going to elicit some reward. Think of this as like a Pavlovian dog kind of thing, right? It presses one button, and it gets a reward, and it presses another, maybe there's no reward, and then it incentivizes that agent, or in this case, a dog, to keep pressing the button that gives it a reward, right? We can think of agents actually in a similar context. I think most of us think about them as these lang chain tool calling things, but I think in the last 6 months, we've kind of seen a convergence, both of these agents that we think about in the GenAI world and agents in the RL context. And we'll kind of show on Databricks how this is being built out. So just some other fun things here. I'm not going to spend too much time here. This is just more traditional RL notions of things. And when you start to think about your models in this way, it can be a really powerful way to think about new ways in which we might optimize them, make them self-improve over time, et cetera. In traditional RL, your thermostat is an agent. Temperature goes down, OK, it needs to then turn on the heat. Temperature goes up, it then needs to turn on the cooling, so on and so forth. This is also called dynamic programming, or linear programming is another kind of flavor of this. Let's talk about GenAI agents. There's a bunch of different ways to refer to GenAI agents. You can see all of the different questions that you might be asking yourselves. I am the GenAI product specialist here at Databricks, and even I, kind of play fast and loose with these terms because customers have different expectations of what these things mean, and you really need to align well on definitions. But we'll talk about what things look like in more official Databricks terms here. So kind of the one that I think most of us are familiar with are conversational agents, right? You're going to have this conversation. I realize the colors here might be terrible, so apologies, I can't zoom in, unfortunately. But you kind of treat the agent as this collaborative, iterative agent that is going to have this conversation, and ideally, by the end of that conversation, resolve some task or issue that you might have, right? It's kind of based around taking actions and responding back to you in this multi-turn setting. Ideally, there's also some memory, so it actually remembers what you said, not just in the last prompt that you sent it, but for all of the chat history, right? You think about ChatGPT, it's this. This is kind of why there was so much ChatGPT hype, right? As part of this, there's also tool calling, right? So tools are going to enable your agent to do very specific tasks. And oftentimes you're specifying a lot of the constraints as well as a kind of workflow that any one tool might take, right? Maybe that's an API call, right? A lot of us have maybe heard of MCP. MCP servers are meant to make it so that tools can communicate more effectively with LLMs and vice versa. We see this as being really integral to people building agents today. But you can also think of tools, going back to that traditional RL view of things, as actions that your agent might take to get rewards later. Rewards probably from you as an end user or your customers, right? And then we have tool calling agents. So there's a lot of different steps here. We're going to do reasoning. We're going to combine that with our different tool calls. And then we're going to perhaps call additional tools as time goes on. This might iterate, right? Ideally not indefinitely, but in a way that until the user is happy, right? Until we see the feedback that we need to say, hey, this is my final answer, or this is satisfying the user's request, that we're done, right? And so there's always this kind of fun looping functionality in this until we get to, in this case, helping someone return some order and giving them a shipping label. We also see this called a function calling agent. We see agents using MCP as part of this as kind of a more modern iteration of this. So if you're, again, what the heck, so much information here, think of an agent as an LM acting as if it had a brain, being able to take actions, right? Being able to reason, doing all of these things to ultimately have some final output here. This is, again, the Databricks official terminology. If you disagree with it, you're not wrong. All these terms are maybe a little arbitrary, but this is the easiest way to think about it, especially in the context of all that RL stuff. So let's talk about kind of how we unite these two areas, right? Because I think for most of us here, this might be a totally new concept. When we see agents today, I'm borrowing these slides partially, or like concepts from this really great blog from Anthropic. Highly recommend checking it out to kind of dispel with this notion that like, wow, agents are so mysterious and complicated. How do I do them? Sometimes your agents are just pipelines. You're taking data. You're making some changes to it. You're spitting it back out to a user. Guess what? We've been building data pipelines for ages, right? Like that is the backbone of Databricks. Oftentimes there's a low degree of autonomy, and there might be non-trivial engineering required. If you're a data engineer, right, like this is something that we're all kind of used to, and we actually say, hey, this is a good thing, right? I don't want there to be this non-determinism in my workflow. I don't want there to be hallucinations as to whether or not I match up data or send off data to some non-secure place, right? Alternatively, there's kind of this more iterative approach, which is that second diagram that you see on the bottom there. In cases where we see tight feedback loops, hopefully you're starting to see like the RL picture side of things, right? When we say that there's a tight feedback loop, that means we're taking the rewards that we might get in the case of like some of these IDEs like Cursor. I'm saying, oh, this code works, right? People talk about verifiable rewards. That just means, hey, do I have a reward that I see as being clearly defined? In the case of coding, this is obvious, right? Does my code run? Does my code actually output something, or does it fail? Great. I'm going to go back. That's like a negative reward. I'm going to go back, rewrite the code until it actually does work, right? I think for a lot of us, this is our lived experiences as people coding in 2025, right? We take our code, we vibe code it, we pass it, we try to see if it's right. We're like, what the heck? We go like tell ChatGPT that it's terrible at coding until it actually gets something right, right? But ultimately, there's this kind of repeated Q&A process, right, in which we're able to iterate and get to something that is ultimately more powerful than some initial baseline, right, without good priors about what we want as a good output. So classic RL, again, is giving us a way to think about how we might optimize this, right, how we might take the agent feedback. So agent feedback, right, that might be me in my IDE saying, yeah, this code sucks, this code is great, right, or right? It could be another judge that is an LLM. Or it could be a subject matter expert, right? If people here are familiar with review apps, right? That is an easy signal for us to take and then actually optimize our systems against. So just to kind of illustrate this at a higher level, like the future of both, not just Databricks, but I think for a lot of folks is to unite this vision of traditional ML or traditional reinforcement learning and GenAI, right? And RL is kind of the easiest, clearest way for us to be doing this. For agents, there's still a lack of definitions here because the field just kind of said, oh, who needs evals? Evals are, second place. I was just talking with a customer. They're building all sorts of cool stuff in LangChain, and I'm like, well, like what accuracy does it get in there? It's, oh, I don't know, like it doesn't hallucinate that much. That's not helpful, right? We would think about this as a problem with a clearly defined KPI for traditional ML, right? We jumped the gun on saying evals are important, not Databricks, right? We have MLflow, we've had MLflow forever. Works great for agents too. But RL is gonna present us a path towards getting even better agents or topic models or recommender systems that ultimately have more autonomy, more flexibility, and are going to be more robust as we get more and more feedback from customers or from whomever your end users are. You can do this to some degree with a library called DSPy, really helpful and popular for building agents. But I think at the end of the day, like all of us here are fundamentally doing some flavor of engineering, right? We still need to figure out how to maybe do prompt engineering as part of our agents or build out these other capabilities that are not as easy as automation. This is all to say, like, we still need us, right? We're essential, and we are always going to need humans in the loop no matter what with these things. With that being said, that loop is something that we can make more efficient end-to-end on Databricks today. So this is like kind of one of the last slides that I have as part of this presentation. We normally present this in customer meetings, but I kind of messed around with it a little bit. So this hopefully reminds some people of the RL diagram that I presented right before this, right? You're going to have this agent, right? We have all sorts of capabilities for you to experiment, to build, to combine maybe traditional ML models with these agents. There's going to be this really nice governance layer on top of all this, because frankly, we need it, and it's essential for people like us who have enterprise use cases, right? You're not going to production with a non-governed system, but the system is something that we can start to think about improving, right? That we can monitor, that we can use that signal from to then loop back around and improve this, right? And so ultimately what this actually starts to look like is what we had before, right? We have our agent, it takes some actions, it produces some outputs. Our subject matter experts, our customers, maybe myself as an AI ML engineer say, oh, this sucks. Like, I need to improve my prompts, right? I need to maybe do some automatic re-optimizations, right? And ultimately, these two worlds are a lot closer than I think we have given credit for, and we should really be looking to RL as a way for us to think about how to improve these things over time and get to solutions that are going to solve our business problems that are hyper-specific, that don't have universal solutions. So yeah, I want to end that here. I'm going to get into a demo. If you want to see more stuff about DSPy or more general like RL-ified agentic workflows, things of that nature, I'm on Twitter or X or whatever you want to call that. But yeah, I'll get into a demo, and we should still have some time for questions at the end. Sweet. OK, so let's talk about this demo here. So pretty straightforward. This did not take me that long to actually code up. We're comparing LDA versus this paper called Topic GPT. I had that link to it. It's by Pham et al. 2024. And what we want to do here is we just want to compare LDA versus Topic GPT. We'll see in this case, guess what? The traditional ML algorithm sucks. Maybe with sufficient data engineering we could get there, but it's a lot of work. Let's see what LDA looks like. We're going to load in this data set. I think it's on like congressional bills or like House bills. You can see the information here. It talks about what this actually is about. And I think our ground truth topic is going to be the subject top term here, right? So this is about education, apparently. And we actually have 21 different topics that we'll try to classify this into. For anyone who's done LDA before, you're probably already going like, oh, God, like this is not going to go well, right? Fortunately, the text is pretty similar in terms of size. But what you can see here is LDA produces topics, right? This is a topic. This is helpful, maybe. If you start to actually read this, I don't know, patient services, health, family, drug applicant, I don't know. There's not a lot that actually differentiates these. OK, biofuel, that's pretty unique. But I don't think these words really have much. OK, never mind. They're somewhat renewable and fuel. So maybe that's a case where the topic actually is being produced in a somewhat reliable way. But also, I don't think about topics this way. Topics should be one word, not just a bunch of keywords, right? That is how LDA works. That is why LDA might not be the best solution for you. Let's keep walking through this, though. In this case, I'm going to just pass this to actually get the topics that are predicted by LDA on each of these. So you can see here, I'm actually computing some features, and then I have a predicted topic. And I could say, yes, clearly this is topic 4, which, again, if we want to go reference this back, it's this one. Act Secretary requires SEC amendment state. Very descriptive. It's not that descriptive. So let's keep going on here. LDA, we're going to go ahead and get predicted topic keywords. It's kind of just mapping those topic numbers to the actual words there, which, again, like I said, not that informative. So then the last step that we'll do here is I'll just format this nicely, because then what we can do is just pass this to MLflow with a custom LLM judge. So in this case, I'm going to say the topic keywords must contain keywords relevant to the ground truth topic. And what this will do is it will provide a means for us to then say, hey, is this an actually good model, right, by using LLM as a judge. You might be saying, wait, where's the judge? It's just in MLflow.evaluate. So for all of us here who are super familiar with traditional ML, right, showing you this should look pretty familiar. This evaluator config is something that's net new GenAI, and also specifying this model type. But you can also specify model type equals linear regression or something like that, and it'll give you nice linear regression metrics, right? What's nice about this, though, is within the Databricks notebook environment is we can get eval results just like this. The Wi-Fi was being terrible, so I won't actually click on this, but it will open up an MLflow experiment. This is not too great. We get 25% accuracy, right? Because as it turns out, our LDA-based topics are not all that informative. So, then the next question is, well, what do you do from there, right? In pre-GenAI land, we would say, oh, we just need better feature engineering, or maybe we need to try and do some stemming and lemmatization and try all these fun old school NLP techniques. They're not going to be very fun. We're going to spend a lot of time stuck engineering this solution and not enough time actually solving our problems. So that's where Topic GPT comes in. I kind of cheated here. I don't actually have the code for Topic GPT in this notebook. I just took the outputs. That's fine. But you can hopefully see that this is actually going to be helpful for us. I'm just reading in the data set here. And you can start to see, like, oh, this is actually kind of a useful topic, right? We're saying that this is about social security. This one's about education, environment, health, so on and so forth, Native American affairs. Let's just vibe check this one, see if it's actually about that. Sorry, just need to, oh, does this not, it might not want to scroll because I'm, okay, there we go. Which one was Native American? That was that one. As it turns out, the subject top term actually is Native American, and if we wanted to, we could click in and see like the actual text of it here, and get some sense that that is actually right. Yeah, it's talking about some like tribes' water rights, right? Awesome. Like clearly, Topic GPT is helpful there. But again, I feel like a lot of us would say in GenAI land, oh, looks good. Like let's ship to production, right? No. Like think of having an eval data set. It's traditional ML. We just are solving it in a different way, right? So we need to do the same exact thing we did before, where we take our outputs. We're going to use LLM as a judge here again. This is effectively the same term, or the same like prompt that we used. And we need to make sure that we have keywords associated with it. This is the same exact code for this GenAI system as what we had for the LDA-based system. It's the same problem. We just have different outputs, and then we want to compare them. MLflow is totally agnostic to what those underlying models might look like. I see some people with agents, and the agents aren't even agents. They don't call a model. They're just if-else statements. Cool. If you want to call that your model, go for it. With MLflow, we're totally agnostic to that. I did cancel this output, but I have one where it did actually run both of these. And you can see this is actually the Topic GPT one. It does marginally better. As it turns out, LLMs are also not the solution to all of our problems. I probably could have done a little bit more prompt engineering here. I only spent a day or so building this out. But if we wanted to then go in and say hey, how do these compare to each other? This is in the MLflow side on Databricks. We can actually go through any one of these and then see kind of the comparisons of what was generated in this case by our LDA model and the GenAI flavored model, right? I'm not going to go through all of these, but the bigger point here is we can kind of think of MLflow as being a neat way to unify the worlds of GenAI and traditional ML, and make it so that that transition is not something that is quite as scary as it might seem to be today, right? GenAI is just a new way of solving the same problems that we have always had. Maybe there's some new problems we can solve that we didn't have the ability to solve before, but I really want to hope everyone can take this away today and say, hey, with Databricks, right, whether we were doing traditional ML or GenAI, we have a unified platform for doing both, moving between the two, and ultimately finding the solution that works best for our business-specific problems. So. I think with that, I'm done. You can see there's an improvement in performance, but yeah, happy to take any questions for the last 6 minutes or so. Cool. Thanks everyone. Yeah, I'll probably stick around for a little bit.